Rubric Academy. Learn it, teach it, remember it, 60 minutes, one whiteboard, and one open-ended prompt. That is a high-level design interview. Today I want to show you something most candidates never get told. That hour is not improvised. It has a script. And once you can read the script, the whole round changes. Here is a full hour laid out as a bar. Now watch how a typical candidate spends it. They hear the prompt and they start drawing. Boxes, arrows, more boxes. The drawing swallows the hour, minute after minute. And the part at the very end, the part about what happens when things break, gets squeezed into one rushed sliver. Here is the uncomfortable truth. The diagram was never the point. The interviewer is holding a scorecard with 5 axes, and drew many boxes is not one of them. Running out of clock, not missing knowledge, is the single most common way this round is lost. So the question that decides the hour is simply, where should the time go? Strong candidates walk in with a different bar. The hour splits into 8 phases, each with its own job and its own minute budget. About 3 minutes to frame the problem. 7 for requirements. 7 more to size it with real numbers. 5 for the interface. And you're not pretending the cache was always a shared cluster, you're upgrading the design out loud in real time. 14 for the deep dives where the round is really graded. 9 protected minutes for failure modes. And 3 to close. Look at the shape of that bar. The diagram gets 12 minutes. Failure modes, the section most candidates never even reach, gets 9. Where the hour goes is a decision, and the strong candidate has made it before walking in. While you talk, the interviewer is filling in a rubric. 5 rows. Requirements. Estimation. Design. Deep dives. And communication. 2 things follow. First, every question they ask is aimed at one of these rows. How much storage will this need is not small talk, it is the estimation row asking to be filled. What happens when the cache goes cold? That is the deep dive row. The interviewer is not trying to trip you. They are handing you chances to score. Second, the phases exist because of the rows. Each phase of the script buys evidence for one axis. And a phase you skip is a row you leave blank. So let us walk the script, phase by phase, and I will keep the bar and the scorecard in the corner the whole way. Phase 1, the problem, about 3 minutes. The prompt is deliberately vague. Say we get design a link shortener, a service that turns a long web address into a short one, and sends anyone who opens it on to the original. A strong candidate does 2 things and refuses a third. First, restate the problem in your own words and ask, is that the right framing? Finding out now costs 30 seconds instead of 30 minutes. Second, announce the plan out loud. Requirements first, then the numbers, then the design, and protected time at the end for failure modes. That one sentence starts filling the communication row before anything is drawn. And the thing you do not do. You do not touch the whiteboard. Every box you draw before requirements is a guess. Phase 2, requirements, and now you drive. They come in 2 kinds, and you name them separately. Functional, what the system must do. Create a short link. Redirect anyone who opens it. Maybe custom aliases. Write them as a list, because a list you both look at is an agreement, and a paragraph is a vibe. Then non-functional, how hard it must do it, and here the discipline is, ask, never assume. How many new links a day? Call it 100 million, says the interviewer. How do reads compare to writes? People create a link once and open it constantly, so call it 100 reads for every write. And the redirect must feel instant and stay up. Now pin that ratio where you can both see it, because every decision after this will be judged against it. A written list with numbers the interviewer nodded at. That is the requirements row lit. Phase 3, estimation, and here is the rule that separates a senior answer from a memorized one. Never assert a number you can derive. It will be about 1,000 writes a second, stated from nowhere, is worth almost nothing, even if it happens to be right, because the interviewer cannot grade a number they did not watch you build. So build it. 100 million new links a day. The senior move always couples the deferral to a working. Divide, round hard, and you get roughly 1,160 writes every second. That number was derived, not asserted. Now the ratio does the next one for free. 100 reads for every write means about 116,000 redirects a second. One multiplication, and you now know the most important fact about this system. It is overwhelmingly read heavy, so the read path is where the design effort goes. One more. Each record is around 500 bytes. That is about 50 gigabytes of new data a day, and over 5 years, a little over 90 terabytes. Big enough to plan sharding for, small enough that storage is not the hard part. And notice, every derivation ends with a conclusion. A number that does not change the design is trivia. Phase 4, the interface, about 5 minutes, and the shape matters more than the syntax. Our shortener needs exactly 2 calls, so draw them as exchanges in time, not a list of names. Creating a link. The client sends the long address and the service answers with the short key. Following a link. The client asks for that short key, and the service answers with a redirect, go here instead, pointing at the original address. 2 calls, each tied straight back to a requirement, each with its answer named. And this little diagram is quietly setting up everything that follows, because these 2 exchanges are exactly the 2 journeys our architecture will have to serve. Now the design phase, and before a single box is drawn, the move most candidates skip entirely. You weigh options out loud. 4 moves, 90 seconds. Move 1, present your primary. For a shortener, the interesting decision is how short keys get made. Primary, a counter. Every new link takes the next number, written as a short string of letters and digits. Move 2, name one real alternate. Hash the long address and keep the first few characters. Move 3, compare against your own numbers. The counter guarantees every key is unique, but it is shared state you must keep alive. The hash needs no coordination, but 2 different addresses can land on the same short key, so every write must check and retry forever. Move 4, commit in 1 sentence. At around 1,200 writes a second. A counter handing out blocks of numbers is easy to keep safe, and never colliding is worth more than being coordination-free. I will go with the counter, and I am happy to revisit. It depends is a description. A commit is a decision, and it is the design row starting to fill. Now draw and narrate every stroke, because a silent diagram is a dead artifact. The spine is almost always the same. Clients at the edge. A load balancer. A stateless application tier. And behind it, the stateful things, a cache, and the store holding the key to address table. Then the move that makes a diagram live. Walk a request through it. The write. A create request enters at the balancer, lands on an app instance, takes the next number from its block, writes the record to the store, and returns the short key. The read, and remember, it is 100 times hotter. It goes to the cache first. On a hit, we answer straight from memory, and the store never even hears about it. Only a miss falls through, and the answer is written back on the way out, so the next 100 readers hit. 2 journeys, hop by hop, every hop doing a named job. A box no journey touches should not be on the board. That is the design row earned. Around minute 35 the probing starts, and this is where the round is really graded. The probes are not random. They aim at the sharpest edges of your own design. What happens when the cache goes cold? Then every redirect misses at once, and the whole read load stampedes the store. The fix is request coalescing. When 1,000 readers miss on the same key, only the first one goes to the store and everyone else waits for that single answer. One fill per key, not 1,000. What if one link goes viral? A single For a read hotkey, the cache is exactly the right tool. The first read fills it, the next million are served from memory, and if one cache node itself becomes the hotspot, replicate that entry. And how does the store grow into those 90 terabytes? Split it. Shard the table across machines. Our keys come from a counter, so ranges of numbers make natural shard boundaries, and any app instance can tell from the key alone which shard to ask. Notice the pattern. Every probe is answered on the board. Something fails, something multiplies, a path reroutes. That is the deep dive row filling. Minute 48. The section most candidates never reach and the strongest differentiator on a senior scorecard. First, the answer that fails here, we would add retries. No scenario, no metric, no mechanism. The discipline is a 3-beat pattern, component by component. How it fails, how you notice, how it recovers. An app instance dies. You notice because the balancer's health checks stop coming back and that instance's errors spike. Drawing a service. The application tier. Let me draw two services here, a feed service and a user service. They're separate because we kept the app tier stateless. The cache dies. You notice because redirect tail latency jumps at the same moment store reads surge, two graphs moving together. It recovers by coalescing the misses, warming the hottest keys first, and if the store still struggles, serving slightly stale answers for a while, because for a redirect, a few seconds old is fine, and saying that trade-off out loud scores on its own. A store shard's primary dies. You notice because writes to that shard start failing and the replica's heartbeat goes quiet. It recovers by promoting the replica and letting clients retry safely because a retried write carries the same key, so applying it twice lands the same record. 3 components, 3 detect and recover pairs, all on the diagram you already built. That is a close an interviewer remembers. Phase 8. Do not let the round just stop. 30 seconds, 3 sentences. The requirements you designed to 100 million links a day, 100 reads for every write. The choice you committed to, and why. The counter. Because never colliding beat coordination free at your scale. And the one thing you would revisit at 10 times the scale? 30 seconds that replay your best evidence right while the interviewer is deciding what to write. And with it, the communication row lights, and the scorecard you have been buying evidence for all hour is full. One more tool for the day it goes sideways, and it will. 4 checkpoints. 4 glances at the clock with a pre-planned move instead of panic. Minute 10. Requirements should be pinned with numbers. If not, stop exploring, ask the 3 scale questions directly. How many a day, what ratio, how fast, and move on. Minute 20. You should know your primary approach. If you are still weighing, commit now with 1 sentence and fold the alternate into what you would revisit. Minute 35. The core diagram should be standing. If it is not, leave the unfinished parts as labeled stubs, say you are doing that, and move to the dives. A complete probe discussion with a stubbed diagram beats a perfect diagram with nothing after it. And minute 50. Whatever is unfinished, drop it, mid-sentence if you have to, and say why. I want to protect time for failure modes. Saying that sentence out loud scores points by itself because protecting the close is exactly the senior instinct this round is testing. So here is the whole hour in 4 lines. Announce the plan. The hour has a script. Show them you know it. Derive every number. Never assert what you can build in 3 short lines on a napkin. Commit out loud. options, trade-offs, then one sentence that decides. And close on failure modes. Detect and recover component by component. Protect those minutes like the round depends on it, because it does. From here, the rest of this course is exactly this script performed for real. Full hour-long rounds on classic systems with this same bar, this same scorecard, and the same napkin math on screen. Watch the script win a few times, and then go run it yourself. Want to keep learning? Come find us at academy.rudewrite.com.